Section 6.3 is on square root functions and inequalities. So the square root function, the basic parent graph, is f of x equals the square root of x. And it looks something like this. So when x is 0, y, or f of x is 0. When x is 1, the square root of 1 is 1. And here I chose, instead of going to the square root of 2, which is approximately 1.4, I chose values of x that you could take the square root of and get a whole number. So the square root of, when x is 4, the square root of 4 is 2, the square root of 9 is 3. So that gives me these ordered pairs, and the basic parent graph of a square root function looks like this right here. Notice that x cannot be a negative number. X has to be a positive number, because if we have a negative number under here, we're going to have the square root of a negative number, which is imaginary, and we're dealing with real numbers right now. So whatever's under the square root has to be a positive number. So x has to be greater than or equal to 0. Now the broader function, which can be translated, so you can take this basic function here, this basic pink curve, move it up or down, right or left, make it wider, go up a little further, make it narrower. You can also flip it over the x-axis. All of that is dealt with the broader function, f of x equals a times the square root of x minus h plus k. This translates the graph up or down and right or left. The point hk, so x is going to stay x, f of x stays f of x, a, h, and k are going to be numbers. The point hk is the vertex or the starting point. And in this case, that would be the point 0, 0. So where does the graph start and then kind of take off from? A, the value out in front, makes it wider or narrower and determines whether it's above or below the x-axis. And you probably remember this similar to parabolas. If a is positive, it's going up, or in this case it would be above the x-axis. If a is negative, the parabola goes down. In this case it would be below the x-axis. The radicand, that is the stuff underneath the radical, x minus h, again cannot be negative because it's under the radical, so x minus h has to be greater than or equal to 0. To find the domain of a square root function, we're going to make the radicand greater than or equal to 0 and solve for x. To find the range of a square root function, plug in the value found above and then solve for f of x. So let's take a look at a couple examples here. Identify the domain and range of each function. Okay, so to find the domain, I'm going to make the radicand greater than or equal to 0. So x plus 2 has to be greater than or equal to 0. Solving that for x, x is greater than or equal to negative 2. And then I'm going to take that value and plug it in to the function. Now because this is a positive, because a is positive, it's going to be greater than or equal to. So I'm going to do f of negative 2, so plug in negative 2, has to be greater than or equal to this function here. So the square root of negative 2 plus 2 plus 5. So that means that is going to be, actually I think I'll leave that f of x. Yeah, I'm going to leave that f of x. So f of x has to be greater than or equal to a positive 5. So that means my domain is the set of all x such that x is greater than or equal to negative 2. And my range is the set of all y such that y is greater than or equal to 5. Now, you will notice that those two numbers that I came up with, the x being negative 2 and the y being a positive 5, are actually my h and k values. Remember, this was x minus h, so this is x minus a negative 2. So h is negative 2, which is what I have here, plus k, k is 5. Let's take a quick look at what the graph of this would look like, and it might make a little more sense that way. So let's go ahead and do the square root of x plus 2, and depending on your operating system, you either want to do parentheses or you want to arrow to the right to get out from under the square root sign. And then we had a plus 5 on the end. So the plus 5 is not underneath the square root sign. Let's graph that and see what it looks like. You'll notice that this point right here, which is my vertex, that's my vertex negative 2, 5. And my domain, what x can be, is all the numbers that are greater than or equal to negative 2. What my range can be is right here, y is positive 5, anything greater than a positive 5. So the domain and range are really very clearly reflected in the graph. Let's take a look at the second example here. F of x is equal to negative square root of x minus 6 plus 5. So let's take the radicand, make that greater than or equal to 0, since that can't be negative. So x has to be greater than or equal to 6. Okay? Now, to find my range, I'm going to plug that into there. So f of x, and I'm going to put 6 in there. Oh, before I do that though, because this negative is here, it's going to be less than or equal to. And we'll take a look at the graph of this and I'll show you why that is. So f of x, my y values, have to be less than or equal to the negative square root of 6 minus 6. So in other words, put that in there, plus 5. Or f of x is less than or equal to, well, let's see, so that would be the negative square root of 0, which is just 0. So f of x has to be greater than 5. So my domain is the set of all x such that x is greater than or equal to 6. And the range, the set of all y such that y is less than or equal to 5. And let's go ahead and graph this one and see what that looks like. So all of my x's should be greater than or equal to 6. All of my y's should be less than or equal to 5. So let's clear that out. So we had the negative square root of x minus 6, and get out from under the square root sign, plus 5. And let's graph that. So notice, here's my vertex. That's the point x equals 6 and y equals 5. All of my x's are getting bigger from 6 on, so x is greater than or equal to 6. And then it's going downward, so all of my y's are getting negative, so y is less than or equal to 5. So the domain and range are very clearly reflected in the graph. So you can always check it by just plugging it into your calculator and graphing it. Now in your textbook they have a chart on all of these transformations, tells you exactly what's going on. I think it's a little confusing. Let's use what we know about where the vertex is and where the graph is going to go to help us to do this a little bit manually and a little bit with our calculator as well. So here we need to graph each function and state the domain and range. So here I have f of x is equal to the square root of x minus 4 minus 10. So my vertex, maybe I should just figure out what my starting point is for my vertex. It's going to be hk. So h is the number that's being being subtracted from x, so that's going to be 4, and then k is the number out here on the 10, on the end there, so that's going to be negative 10. So my vertex is going to be the point 4, negative 10. Whoa, okay. And then the graph of this, because a is positive, it's going to be going up. So let's go ahead and let's jump to the calculator, and let's put this in the calculator and see what it looks like. So square root of x minus 4, close parentheses, minus 10. And let's graph it. Yeah, look at that. So there's my vertex. Okay, that's the point. Actually, I'll look over here. That's the point 4, negative 10. And from there it goes up and heads out. And so let's make a table so I can actually get some points to go ahead and graph this. So I know that, let's do the table. Notice I've got some numbers already in here. Notice I can't have anything less than 4. Look at this. So x has to be, the smallest that x can be is 4, because if x is anything smaller than 4, I'm going to end up with a negative number under the square root sign. So my first x value has to be 4. So I'm just going to go ahead and put that in. And let's just try some other numbers. 5, 6. Oh, actually, I'm getting some. Oh, no, there I got a square root. That's not so nice. 7, 8, 9. Okay, 8 is a nice number. Okay. And I think that's probably enough. Let's go with that. So let's go with the table. What do we have? We started with 4. So 4, negative 10. And then I had, actually, what did I have? I had for 5, I had -9, and then for 8, I had -7, and I think if I go any further, I'm not going to fit on my graph. So let's use those points. So 5, -9, 5, 6, 7, 8, and then I need -7, so something like that. And then looking at my graph, it goes like that, and I'm just going to leave it like that. Okay, so that's the graph of f of x equals the square root of x minus 4 minus 10. Let's go ahead and list our domain and range. So it's a set of all x, and since it's going in the positive direction, it's going to be greater than or equal to whatever the x of my vertex is. 4. My range, the set of all y, such that y is, and because it's going up, greater than or equal to whatever the y of my vertex is, -10. Let's try another one here. So f of x, I forgot to put a graph in here. Let me insert a graph. Okay. So here we have f of x equals -3 times the square root of x plus 7 plus 9. So my vertex, I can figure out what my vertex is. So it's x minus h, so that's going to be -7 plus k, which is 9. I'll go ahead and start there. So 2, 4, 6, 7, and 9. So there's my vertex. And I know it's going to be going down because of the negative. So it's going to be going down a little bit. And that 3 is either going to make it wider or narrower, but at least I have a starting point. So let's go to our calculator and plug it in. So -3 times the square root of x plus 7. Whoops. Close parentheses, plus 9. And let's graph. Okay, so I think that 3 makes it wider. Okay, so that's my vertex, what I was thinking. The point -7, 9. And I knew it was going down because the 3 was negative, and the 3 is going to make it a lot wider. So let's try some different points in our table. So I want to start with a -7, because that was the x I had. Okay, and let's get a little bit bigger. Since it's going to the right, they're going to be getting bigger. So -6, that's good. -5, -4, nope, don't like that one. -3, there's a good one. -2, oops, -2, -1, 0. Is 0 going to work? 0 is not going to work. Okay, and 1. How about 2? Okay, so I've got a couple points there. So let's go with the ones that have whole numbers for the y's. That should give me enough information here. So my first one was -7, 9. And then I had -6, 6. And then I had -3, 3. And then I had 2, 0. Okay, and let's go with that. We'll just graph those for now and see what that looks like. So there's -7, 9, -6, 6. So 1, 2, 3, 4, 5, 6. -3, 3. And 2, 0. Okay, let's just go with that for now. So I think that's enough points. And it's going to keep going out like that. Okay, let's determine our domain and range. Since my x's are getting bigger, my domain is going to be the set of all x such that x is, since x's are getting bigger, greater than or equal to the x of my vertex. Range, set of all y's such that y is, now my y's are getting smaller, so it's going to be less than or equal to the y of my vertex, which is 9. Okay, so you can graph these if you figure out what the vertex is, what's your starting point. You can figure out if it's going up or down. You can figure out if it's going to be a little wider or a little narrower. Use your calculator to help you find some nice points to put in a table and then graph it. Now, you can also graph square root inequalities. So it's going to start with a curve, just as we did in the last two examples, and it's going to be solid if it's a less than or equal to or a greater than or equal to, or it's going to be dashed if it's a less than or a greater than, and then you're going to shade above if it's a greater than, and below if it's a less than. Kind of like we did with lines. Very similar. So let's take a look at each one of these. So first of all, we need to, actually, let's say a few things that we know about it. It's going to be a solid curve because it's a less than or equal to. We're going to shade below the curve. Okay? And I know my vertex is going to be the point 6, 0, because h is 6 and there's no number added out here. The curve is going to be going down, and because it's a 2, it's going to be a little bit wider. Okay, so let's start with our point of 6, 0, 2, 4, 6. Okay, and let's go to our calculator and get some points. So we have -2 times the square root of x minus 6. Okay, and that's what I thought. There's the point, right there is the point 6, 0. It's going down, it's a little bit wider. Now what the graph is not going to do, the calculator is not going to show you, is solid or dashed and where it's shaded. Okay, so let's get some points. And remember, the first x I'm going to use is 6. Notice none of these that were already in there are actually working, so I need to start with 6. And let's go to 7 and 8, 9, 10. Okay, actually I can't go any, oh there we go, 10 is good. Okay, so let's go with that. We'll go with those points right there. So I'm going to make a table. So I had 6, 0, I had 7, -2, and 10, -4, and that's going to be enough points for now. So 6, 0, 7, -2, 10, -4. I could actually, if I wanted to, count by 2's, but this is going to be okay. My graph is solid, so I will draw a solid line here, and I'm going to shade below the curve. Now, I'm not going to go any further to the left than where my vertex is, so all of this in here is what's going to get shaded, only up to that line right there. I'll go a little bit further out beyond here. Okay, so that's the graph of this inequality. It's negative, it goes down, my vertex is 0, 6, it's solid, and I shade below. And let's try this example here. Let's figure out what we know about this. It's a less than, not an or equal to, so it's going to be dashed. It's a greater than, so I'm going to shade above. Okay, maybe I should write shade above. Okay, my vertex is going to be the point -2, because remember it's x minus h, -3. And it's going to be a wider graph, and it's going to be above the x-axis. Or actually, I should, instead of saying above the x, no, it's not necessarily going to be above the x-axis. It's going to be going up. Let's say that. So it's going to start at a point. In fact, let's graph that point. It's going to start at -2, -3. And it's going to be going up. Now, oh, this is actually interesting. I can't put a solid dot there because -2, -3 is not a part of it. I actually need to have an open circle at -2, -3. Okay, so it's going to be going up from there. It's going to be pretty wide, and I need to make it dashed, and I'll shade above it. So let's go ahead and go to our calculator, and let's put this in there. So give us some points. So 4 times the square root. I get square root of x plus 2. Get out of the square root, and then -3. Okay, that's what I thought it would look like. So there's my vertex at the point -2, -3. It's going up. It's pretty wide. Let's get some points to make our table. Okay, I think my calculator is having a fit. It doesn't want to do it. Okay, well, we're just going to have to go with it. I've already made the table. Do the table in your calculator. You want to start with your x being -2, okay, and you know that your y is going to be -3. That's our vertex there. Put in some other values. I already did that. When x is -1, y is 1. When x is 2, y is 7. When x is 7, y is 9. Okay, so let's go ahead and graph those points. -1, 1, 2, 5, and 7, 9. This graph is going to be dashed, so I need to put some dashes in between there. So curving dashes. Okay, and I need to shade above the line, and I'm not going to go any further to the left than I have here, so it'll be shaded in here like this. Because I'm shading above the dashed curve. Okay, so this is the graph of y is greater than 4 times the square root of x plus 2 minus 3. So again, figure out what you can from the graph, just looking at the graph, what it's supposed to look like. Punch that into your calculator. Make your table, starting with your vertex. My apologies for my calculator program not working there. But pick some values, pick some nice numbers, graph them, and shade where you need to.